During my postdoc, part of my job was mentoring three new PhD students and also redesigning the Phasr reactor and fabricating a new reactor for the study of plastic pyrolysis. With this system, we can do isothermal experiment. We can rapidly heat the sample to a designated temperature like 500 in a 20 millisecond. Then we can hold it at that temperature for a time such as 100 milliseconds and rapidly quench it and analyze the product with gas chromatography. This is the only system which we can do the isothermal experiment for plastic pyrolysis. And also you can see a CAD file and the picture of the reactor. We recently submitted a paper about this new reactor with title of on the method of pulse heated analysis of solid reaction for polyolefin pyrolysis. And also here you can see the way I designed it is very user friendly and you can easily install it in the gas chromatography. This is what the Phasr reactor look like inside. The Phasr is comprised of an upper heating block and a lower cooling part. And in experiment, we apply current and voltage to rapidly heat the thin film sample. We use these two electrodes to apply current and voltage, and there is an optical pyrometer located directly above the sample that measures the temperature and feedback to the controller to control the temperature. And there is also a silicon-based fluid flow below the sample in the heat exchanger that rapidly quench the reaction. And this is also you can see also a picture of microcoolant heat exchanger. There is a ceramic insulator that prevents the copper from shorting out and a sample holder made from low carbon steel, and then we have the sample. Helium gas also flow rapidly above the sample to sweep away any product that forms, and it's then sent to the gas chromatograph, which is connected to the system for further analysis. With this technique, we can see the kinetic and chemistry of material in the time scale of 20 milliseconds. With this system, we can take a thin film sample of material, rapidly heat it to the designated temperature like 500 in 20 milliseconds. Then we can hold it at that temperature for a time such as 100 milliseconds and rapidly quench it in a less than 100 milliseconds and stop the reaction. So we can stop and start the reaction, analyze the product, and then plot the data function of time. For example, here is some of the data which we obtained from a Phasr reactor. We kept the sample at 500 C for 50 milliseconds. Then we quench the reaction, and then we analyze the product. Also, we repeat this experiment for different pulse times: 70 milliseconds, 100 milliseconds, and 200 milliseconds, and 500 milliseconds, and 2 seconds. After doing this experiment, we can use mass spec to identify each peak, and then we can plot it separately. For example, this is one of the peak, which is furfural, and we see what's happening for each individual product with time during the pyrolysis of here, for example, biomass or plastic.